with that, Andrew, thank you for the patience during the introductions. Do you want to go ahead and start the deck? So we're here talking about secure multi-cluster Kubernetes with Linkerd.
All right. Thank you so much, Jason. So a little bit about myself. I'm a software engineer at Buoyant. I'm one of the maintainers of the Linkerd project. These are some of my social media accounts. It's usually Alpeb at Twitter, GitHub, and in Buoyant Slack, it's Alejandro at Buoyant. So feel free to contact me even after the workshop to ask me any questions. I will be more than glad to answer. Okay, so for today's agenda, the beef of it is going to be a demo, hands-on demo. The idea is for you folks to follow along. So let me know if my cadence is too fast. I pasted in the Slack channel this URL for the GitHub repo that contains the list of commands that I will type. For these, you need 2 clusters ready. If you don't have them ready, you can take advantage. First, I'm going to go over an overview of Linkerd's implementation of multi-cluster. That's going to take about 15 minutes. So if you don't have your clusters ready, you can do it now. In the demo, I'll be using 2 GKE clusters because we're going to have 2 clusters, west and east. The east one needs to be able to create load balancer services accessible from the internet, or at least from the west cluster. So the easiest is to do that through public clouds. I'm using 3 nodes per cluster because we're going to be installing Linkerd DVs as well, but that's not required really. It's just for 1 command. So if 3 nodes is too much for you, it's okay. 2 should be good as well. And usually in local testing, I use K3D. Hey, that's Jason's face. Nice to see you. I use K3D, but that requires some extra flags. So it's easier just to go with a public cloud for this demo. All right, so let's get started with the brief multi-cluster overview. First of all, let's talk a little bit about why do we want multi-cluster. So we want to frame these around Linkerd's 3 fundamental pillars, which are security, reliability, and observability. What are the use cases for multi-cluster? First, we might want to deploy the same services across different multi-clusters, across different clusters for failover purposes. If services or the entire cluster starts failing in some region, we can fail over other regions. So that deals with the reliability aspect of things. The other use case is to actually spread different services among different clusters. If we want, for example, to segmentate services because we have different teams in our organization, and we want to give the responsibility of each team to provision and maintain their own separate clusters. So multi-cluster will give you this functionality in a secure way. Also, you might need, for regulatory reasons, to have services in different jurisdictions, so you can't isolate them in separate clusters, et cetera, et cetera. And well, there are multiple ways to skin the multi-cluster cat. Linkerd's implementation is very opinionated because we want to fulfill these 3 fundamental goals. First, we want to continue being fully transparent to apps, as we've always been. The idea for multi-cluster is for apps to not have to change in order to benefit from all the good things that a service mesh provides. We want to keep the same when using multi-cluster. The only change you would have to make is if you want to connect to a service in an external cluster. Obviously, since they are in different networks, you cannot use the same FQDN. You would have to connect to the mirrored service in your local cluster. We will see what that means in the demo. And so that would be the only thing you would have to change in your apps. Secondly, we want to be independent of network topology. One possible implementation of a multi-cluster is just to deploy your different clusters using the same network IP address so that each pod can communicate with any other pod in the clusters without having to rely on a service mesh. We didn't go down that road because we want to keep clusters to be totally separate amongst other reasons, so that they have the different failure domains that are not at all, you don't need common configuration between them, not only for simplicity, but also, yes, to keep different failure domains. And the only thing you need is to have the clusters being able to expose a gateway. And we'll see how that works in a moment. And finally, we want to avoid global state. This means that you don't have to install some centralized control plane coordinating all the clusters. In our approach, each clusters have a separate Linkerd control plane. They don't have to know, they don't have to have a common configuration. The only common thing is a common trust root. So I'll talk about that in a moment.
What's the advantage of avoiding like a global state or like a global config for this thing?
So that you can bring extra clusters without barely any configuration. That's mainly the reason, I think.
Awesome, thank you.
Okay, so as I said, the only requirement is for clusters to share the same trust anchor. So you see that here at the bottom. In this example of West and East, each cluster, well, Linkerd is, first of all, security model relies on a hierarchical chain certificates. At the bottom, we have the common trust anchor, and then each cluster can provide their own separate issuer certificate. And that certificate is used by the Linkerd control plane to issue short-lived certificates to each one of the clusters, to each one of the proxies. Those short-lived certificates live by about 24 hours, I think. And so, for example, you see on the left, the usual case where service A wants to connect to service V. So that is done through the proxies, through MTLS. And that means that each one of those proxies will validate the identity of the other proxy by checking against the common trust anchor. When Linkerd injects the proxy, it also injects the trust anchor as an environment variable into the proxy, so they know what that certificate is, and that's what they use to validate connections. If we bring an additional cluster here, East, so we have to install an extra extension, Linkerd multi-cluster, in both clusters, and that gives us an extra component, the multi-cluster gateway, that is responsible of routing all the connections that come into the cluster. One thing that I didn't picture here is the service mirror controller. That, for example, if I want to expose service C in the West cluster, I would add a label into the service C that gets detected by the controller on West, and it will create a mirror service. Of course, the target pod remains on the East cluster, and the controller also associates an endpoint to that service, and that endpoint points to the IP of the gateway on East. So if service A wants to communicate to service C, the proxy will use that endpoint, and it will reach the gateway directly on East, and that gateway will route the connection to the appropriate target cluster. So if you want to know more details about how MTLS works, Jason just pasted a link to a previous workshop we did by Matei, specifically on the topic of MTLS. Okay. Now let's talk about failover. So this is provided as an additional extension called Linkerd failover that we released a few months ago. This is supported only as of Linkerd 2.11.2 that we released 1 or 2 weeks ago. That relies on the traffic split CRD. That CRD is defined in the SMI project. If you know SMI, that's Service Mesh Interface. That's a project that attempts to put under the same umbrella some common service mesh concepts. In 2.11.2, we have included the definition of that CRD in the Linkerd installation, but as of Linkerd 2.12, that is not yet out, we have removed that, and instead we require that you install the Linkerd SMI extension that contains all the SMI related stuff. So, but for the demo, we will be using 2.11.2, so we don't need to install that extra extension. This is a first approach to failover. It uses the simplest possible way of doing this. The criteria for failing over from one primary service to a list of secondary service is the pod readiness of those secondary services. So it's very simple. So as I said, this is a first step of this problem. There are many ways we can improve. For example, Kubernetes now provides topology awareness hints where you can declare in endpoint slices whether you want to keep connections inside the same zone or things like that. In Linkerd failover, we use traffic split, and traffic split only cares about services. So we are not surfacing those topology awareness hints, but we can do that through some means in the future. Another way we could improve things is instead of using pod readiness, we could use latency. So instead of waiting for a pod to completely fail before doing the failover, we could watch its latency and do the failover when it starts becoming slow. Also, currently, if the primary service fails, we immediately fail over the secondary services. And whenever the primary service gets back online, we switch over 100% of the traffic back to it. So that might be too abrupt. So one possible improvement would be to use a circuit breaker pattern in which we watch the health of the primary service and progressively switch traffic back to it instead of doing wholesale. Anyways, and if any of these cases interest you, or if you have additional use cases, please let us know in the Linkerd repo, raise an issue. So that'll help us to properly prioritize what we're gonna do in the future for these extension. Okay, so we're gonna start with the demo. What we're gonna do, we're gonna start with one cluster. We're gonna install Emojivoto, which is the app we always use for these kind of demos. Then we're gonna add another cluster. We're gonna route some of the services from one cluster to the other. And then we're gonna have parallel installations of Emojivoto in both clusters and introduce failover. So whenever one service fails in one cluster, we can use the service on the other cluster. All right. 1 second. Any questions so far? Okay, we're good.
We're looking good.
Awesome. So I have here on my screen, top left, the west cluster, top right, east cluster. Okay, I'm gonna switch to the context of the west cluster. I have alias kube control to K for speed. So, okay, we're on west now. I'm going to install emoji Vodo. Okay. And we're gonna use it and see if it's working. So for that, I'm going to port forward the front end. Let's check it out. There you go. You can vote for your favorite emojis. And you can check the leaderboard. There you go. Okay, so this has some components. Vote bot, which is a traffic generator. So we can see some stats out of the box that communicates with web, which is the web front end, and that web pod relies on voting, which returns the list of available emojis and sorry, that's emoji. Emoji gives you the list of emojis, and voting is where you persist the votes. Okay. Oops. Okay. So this is the architecture of emoji Vodo, as I just said. VoteBot calls web, and web calls emoji and voting. All right. And what we're gonna do next is remove everything but VoteBot on west, and have VoteBot communicate with web as service on east. For that, we're gonna rely on a gateway that is installed on east, and we're gonna create a mirror of web service on west. Okay, so VoteBot actually calls web, the mirror of web here, and that's gonna rely on the connection to east. Okay. So we're gonna first delete everything but VoteBot. Whoops, emoji. And we're gonna install Linkerd, of course. So this is the bare default installation. It will create the trust root and the issuer certificates by default, some based on some random certificate. And we're going to install these as well. This is not strictly necessarily. If you don't have enough nodes in your cluster, you can avoid this step. We just need this for one command that we'll see in a moment. Okay, so this is gonna take a bit. Great timing for asking questions.
Just for folks out there, if you're following along, just be good to get a heads up or a thumbs up from people if you've been able to access the repo. I see we have one question out there. Do you mind putting your question in the chat, either in the Slack chat or the workshop? And I'm happy to ask Alejandro. And yeah, if y'all can do a little thumbs up reaction icon if that's available. So I'm not sure the emojis are available. Sorry. But please say something if you're having trouble following along. Yeah, I can post the repo link there. Give me just one sec. All right, so the repo link is there in the chat.
Okay, so as a reminder, Linkerd EVs is not required for the multi-cluster functionality, only for one command that we'll use in a moment. We're almost there. So the next step is to install the multi-cluster extension. Okay. So the command is Linkerd multi-cluster install. I'm going to abbreviate multi-cluster to MC for speed. Okay. So the V's extension is coming up. And now Linkerd MC install apply. Okay. So now I want to add the East cluster. Remember, we need to use the same trust root. So I'm going to extract that, the one that Linkerd install created by default. I'm going to extract that. That's stored in a config map called Linkerd identity trust roots. What's wrong here? Linkerd identity trust roots. So I'm gonna call that West root CRT. But let's take a look at that. Obviously, this is a config map. I'm only interested in this part here, so I'm going to remove everything else. Okay. And I'm going to create now the certificates for East. So we're not going to use defaults, but we're going to create some. So for that, we use this command from step, which is a CLI tool. Sorry, I forgot to tell you to install that beforehand. This is the same as OpenSSL, it's just easier to use. So what this does is create a root certificate. It gives us back the actual public key and the private key. And okay, so this is the trust root. Now I need the issuer certificate, which is an intermediate certificate that is rooted at the root CRT that we just created. Here it is. And we get back the public key and the private key, right? So what I'm going to do now is, since when I created the certificate for the East cluster, I created a new certificate, but we need it to be the same as West. We're just gonna bundle them. That's another way of doing things. So I'm going to just use this. This is the one we extracted from West. I'm going to append it to, well, I'm going to append the one from West to the one in East and create a bundle. Let's check how it looks like. There it is. And I'm going to use that bundle. First, I'm going to update the certificate on West to use this bundle. And then I'm going to install East using that same bundle. So for that, I just do Linkerd upgrade, identity trust, anchors file. Okay. Let me see if everything is fine here. Yep, looks good. So we see some pods rotating there. And now I'm going to switch to the East cluster. Okay, and I'm going to install Linkerd using that trust bundle. Identity issuer certificate. All right. And then I'm going to install the multi-cluster extension. We don't need these in this cluster. Okay, this is gonna take a moment. So time for questions if you want.
I saw someone typing, but I don't see anything active right at the moment.
Yeah, Christina is typing.
Okay. Christina is asking if we can show the version of Linkerd and point out the traffic split CRD on the West cluster.
Yes, that's right. So yes, it's version 2.11.12, Linkerd version. And if we go to the West cluster, well, actually, it's installing East as well, the CRD, the traffic split. What do I need that traffic split? Why it's not? Yeah, I'm not saying it yet. Ah, sorry. That's CRD, custom resource definition, traffic split. This is what you want to see, Christina? The CRD. So this is the actual CRD definitions. We're gonna add some one instance of that we will see in detail in a moment. That was Linkerd itself. It didn't, so answering the question from Christina, what installed the CRD? That was, it got installed, the traffic split CRD got installed by the Linkerd install command because it's included in 2.11.12. It won't be included in the upcoming 2.12 version. So for that, you will have to install the Linkerd SMI extension, right? Okay, we're ready here. Now we are going to install an injected version of emoji photo on East. Okay.
So Anvesh has a question about how do we generate the certain question. And I believe they're asking about STEP. So STEP is a CLI tool that you can use to very easily generate certificates. And I'll post the link to that in the chat. And I don't know if you have anything to add there, Alondra.
No, it's fine. Yeah, that's correct. Yeah, you can do it. Usually people do that through OpenSSL, but I think STEP is gaining more traction. It has a much friendlier interface. Okay, let's see the services that we have in the Linkerd multi-cluster namespace in East. So we have this gateway that got created there. That's where all the traffic, incoming multi-cluster traffic is going to come through. And it exposes this external IP. We have two ports there, 41, 43. That's, well, before that pod is a 2-container pod. One of the containers is our usual Linkerd proxy. The other one is just a pause container, so it doesn't do anything. And we are exposing here the port 4143, which is the Linkerd, the usual Linkerd proxy port, and 4191, which exposes the readiness of the cluster. So any other clusters know whether to route traffic there or not. And let's also check the service authorizations. Okay, this is facing the internet, this external IP, but only traffic coming from inside the mesh. So that's proxies that have been, whose identity relies on the trust anchor that all these clusters should share. If not, traffic will be denied, right? And okay, so in addition to that, there's a server authorization resource. So that's in the Linkerd multi-cluster namespace. Server authorization called Linkerd gateway. So this is associated to the gateway, and the important part here is this. So again, we only allow, well, the proxy will reject anything that doesn't have a proper identity, but we also have on top of that this. So only traffic that has meshed identity will be allowed. By default, traffic from any IP will be allowed. But the recommendation in production, of course, is that you put here the list of the other clusters you want to communicate with. Okay. Now, I'm going to delete the vote bot pod on east so that we only have the vote pod from west to the requests. And I'm going to export the web service on east. For that, I just add a label. Make sure this is property mirror linkerd.io. Exported equals true. I think that's fine. All right. And I'm going to create a link. So this is what will allow us to actually link both clusters. So the command is link. I have to provide a name for this particular link. I'm calling it east. And, okay, there it is. So let's take a closer look into what that is. So first of all, this contains a secret with a kubeconfig. We'll take a closer look at that in a moment. That's just a regular kubeconfig file that allows you to connect to the cluster. So this is what the West service mirror controller will use to connect to the East cluster. We also have the link CRD instance. So first we have here cluster credentials secret. That's the secret I just showed you. So this is what will allow us to connect to the East cluster, the IP of the gateway that is exposed on East. Then we have a cluster role so first of all, I generated this while being on the East cluster context, but I'm going to apply this on the West cluster, right? And this cluster role gives me the ability to do anything with endpoints and services because we need to create mirrors on the West cluster. So we need that. It also allows me to list and watch namespaces because we can only create service mirrors as long as their namespace is already there. And we bind that. Okay, so service with the service account Linkerd service mirror East. So that's the service account of the service mirror controller on West. Yeah. And we have a role applying to the Linkerd multi-cluster namespace that simply allows us to retrieve the secret that I showed you first on this file and watch over any links that get created. And we bind that. We have the service accounts we already mentioned and the deployment of the actual service mirror controller on West. Remember, we're going to apply this on West. So this is what is going to create the controller that is going to communicate, is going to connect to the kube API on East using the kubeconfig I showed you. So it can watch over any service that gets exported. And whenever that happens, it's going to create a mirror on the West cluster. And finally, we have a service, which is just for probing purposes. We're going to hit that service, and that as you can see, it doesn't have a target pod because the service mirror is going to manually create an endpoint that whose IP is going to point to the gateway on east, and it's going to hit the probe port that I showed you before, just to see if the cluster is alive. Okay. Oops. And now the kubeconfig that I showed you is going to use this token from the Linkerd service mirror account here. I think it's this one. Okay, so it's going to connect to this using that token. You can this is you have created a service account on east that is tied to that token that is going to be used by the service mirror controller on west. If you have multiple clusters that are connecting to east, you can create different services account, so you can have a better management. You can deny access if you want by deleting those services account. And so if you want to to create all these resources for a new service account, you can use the Linkerd MC allow command. But okay, and service account. So you have to give a name to the service account you want to create. For example, this. I know this is going to fail because this turns out to be broken on 2.11.2. I just realized that. So let me switch real quick to Edge. So I have some command here to switch my Linkerd versions. Edge 2241, and this should work. All right, so let's take a look at that. I'm not going to use that. This is just to show you what it does. So we have the same cluster role service, all the same RBAC I showed you before, but this applies to this particular service account. So if you want to create a new service account to link different clusters, you can use this command. Let's switch back to stable. Okay. All right, let's go back to West. And apply that link. Now let's take a closer look into that kubeconfig that just got applied here. So this is in Linkerd multi-cluster namespace, secret cluster credentials is. I'm going to use some JQ magic to extract that. This is encoded in base 64. Okay, what did I do here? Oh, JSON. Okay, so this is a regular kubeconfig file. And what I wanted to show you is here this token. So this should be the same token associated to the default service account that got set up on East in order to grant us access to the Kube API on East from West. All right. Now let's check if the connection has been established. So we use Linkerd MC gateways. It's working fine. We have one service exported. This is the latency distribution for East as seen from West. This uses Prometheus under the hood. The Linkerd service mirrors, by the way, got created here. And this exposes some metrics regarding the availability of East, and Prometheus will grab that and show us those latencies here. This is why we needed to install Linkerd VS on West, but it's just for this. Okay. And let's check the services in Emojibodo. So we have our usual leftover services from the other components, and the service mirror controller created web SBC East, which is the mirror of web on East. And if we see the endpoints, the associated endpoint to that here points directly to the gateway on East in the proxy port. Okay. Emojibodo isn't injected yet, and it's not pointing to the service mirror yet, so it should be erroring out. Let's verify that. Yep. Now let's try to communicate with the East cluster using curl. So for that, I'm going to create a curl pod. Okay, this is going to die because it completes. So I'm going to edit it. I bet there's a better way to doing that, but I don't know. So let's just edit it. And what should I do here? I'm going to add the sleep. Here. Okay, restart. Okay, so let's, it's running now. Let's exec into it. Okay, and I'm going to curl that mirrored endpoint. SBC East, Emojibodo, SBC cluster.local. Okay, the connection failed. If we check the logs of the gateway in East, we should see the failure. So I'm using the East context here. Proxy. Okay, let's hit it again. And we see immediately the failure here. Connection closed. The array's direct connections must be mutually authenticated. All right, that's what we expected. Now let's try injecting the curl pod on West. Can close this. And it should work this time. So for that, one thing we usually do is just get the deployment and pipe it to Linkerd inject and pipe it to control apply. Okay, now we have two pods here. One of them is the proxy. Let's exec into it again. 6, 9. So this time we have two pods, so I have to specify the pod I want to get into. And let's do the curl again. Web SBC East, Emojibodo, SBC cluster.local. And this time it works. We get back our HTML. All right. Now I want to do the same thing with vote bot. So for that, let's edit the deployment. So first, I'm going to add the inject annotation. One common mistake is to add that annotation at the workload level, but the right way is in the actual pod template. So it's right here below. And currently, VoteBot doesn't know about the mirror service. So we just changed this environment variable here, and we changed the target that it will hit with the mirror service. So this is East, I think. All right. Now let's, it's restarting, and let's tail the log. 6, 6. our bot, and now it's working fine. Awesome. Cool. Now let's do failover. So for that, we're going to do something like this. We're going to have two parallel installations of Linkerd in both clusters. Okay, we will have both bot only on West still, and we're going to set up a traffic split whose primary service is going to be a web service on local on West, and secondary services will be, well, the same web service on West and another secondary, which is the mirror on East. So whenever web service on West fails, it's going to fail over on West on the web service on East, right? Through this mirror here. Okay. So we're going to reinstall emoji Vodo on West, yes, so that we can get back all our pods. This time we inject from the get-go. Okay, in the instructions I have, if you're running on 2.12 or on an edge, you're going to have to install the Linkerd SMI extension to get access to the traffic split CRD. It's not the case here, so we're skipping that. But I do need to install the Linkerd failover extension. Traffic split resource. 1 second. Linkerd SMI. Oh, yeah, okay, not yet. Let's first take a look at how traffic split works. So I have here in my directory a traffic split resource. It's very simple. What matters for us now here is this service. So we're interested in splitting the traffic of the web service, and that's supported by two backends, web service and web service East, which is the mirror from that we set up in the previous steps. Currently, all the traffic is going to web SVC. All right, so let's apply that. And if we tail the logs of the voting pod, we should see some traffic here on West. Yeah, there it is. And I'm going to open another window and tail the traffic of the voting service on East. Okay, so we have no traffic there. Remember, the vote bot is only running on West, so East is not doing anything right now. Okay, now, okay, I'm going to switch all the traffic to East. So let's open yet another window. I'm still here on the West context, so let's manually edit the traffic split. And I'm going to switch all the weight to East and save that. And we see the traffic stopped on West and it started on East. It's working as intended. Let me switch it back. Okay. All right, so the idea of the traffic split operator is to do what I did automatically depending on the availability of those backend services. That's it. So let me install the Linkerd Failover extension. So for that, I need to add the Helm repo. This is done through Helm. We don't have a CLI command for installing this. So Linkerd Edge. If you don't have our Helm repo installed yet, so you should do this. Then Helm repo update. And then I install the extension. Linkerd install, Linkerd failover. This is still as an edge release, so it needs the devil flag. Okay. And we should see the operator here on West. There it is, Linkerd failover. And okay, let me show you one more time that traffic split. So, okay, here. These annotations here, most importantly, this one, failover Linkerd. These flags, these specific traffic splits so that the failover operator watches over it. If we don't set this label, it will just leave it alone. And we have this annotation here, primary service, that specifies which of the services listed here is the primary one, and the other ones will act as secondaries. So the primary is web service on West, and the secondary is going to be the mirror one. Okay, now let's simulate a failure on West and see how traffic flows to East automatically. So for that, I'm just going to scale down the web pod on West. So replicas 0 for web. So I'm going to scale down this guy here. You will see it getting terminated. And immediately you saw the traffic going back to the secondary. It was flowing here and then it went to East. And if we check again our traffic split, we see that automatically the weight was shifted to the mirror here. And the primary got its weight set to 0. And now if the primary gets available again, the operator will switch back the traffic to it. Let's scale it back up. Replicas 1. This is going to take a moment while the pod becomes ready. This one here. You will see the traffic flowing from East to West. There it is. Okay, awesome. All right, so I think that's all I wanted to show you. Let's get back to the presentation. Do you have any questions before we switch back?
Looks like things are fairly quiet. For the folks that were going through, were we able to follow along fairly well? Some thumbs up or comments in the Slack or chat would go a huge way. All right, so with that, I hope you've enjoyed this workshop. We have a bunch more workshops over at Service Mesh Academy, and let me just get you that link real quick. So a bunch more webinars on, from Buoyant on all sorts of things. So, I heard a question about Linkerd Inject. There's kind of a Linkerd overview and how it works session in there. We've got a session on multi-cluster, on MTLS, did one on policy, and there's a lot more going on. Thanks a ton, Adonai, Azhar, thank you. I'm sorry if I didn't say your name correctly. There will be a recording. And yeah, we're so grateful to all of you for attending. So let me just post the link here, both in the Zoom chat and in the workshop channel. And then the next workshop coming up, June 16th, Enterprise PKI in the Cloud Native World with Linkerd and Cert Manager. It's a personal favorite. I love Cert Manager. I think it's a lot of fun. Well, fun is relative. I think it's a cool technology that makes managing certificates way better than doing it by hand. And I bet you'll really enjoy it. And I hope you get a chance to register. There'll be a recording. Slides will get sent out. Oh, and it'll be co-presented with the folks who do Cert Manager, the folks over at JetStack, and now I think Identify. Yeah, really, really great stuff. Beyond that, you like the presentation, you like Linkerd, you like Point? Well, we want you to come join us and help make Linkerd even more awesome. Love to hear from you. Love to hear from you on Twitter, on Slack, anywhere that you have questions or problems. And if you're looking for a role, we'd love to talk to you. And please feel free to reach out to me directly on Slack if you have questions about any of these things, or on LinkedIn if you need any of that. Okay. Andrew, any parting words?
Thank you so much for attending. The demo went well, so thanks for the demo gods. And
yeah, it's always good when multi-cluster things work first time. Well, all right.
We didn't touch on some topics like we recently added headless services mirroring, so you can mirror database nodes and things like that. Can get pretty interesting. So if you're interested in that, we have docs for that in our linkerd.io site.
Awesome. Yeah, great bit. Is this documented on linkerd.io, the failover operator?
Good question. I think not. There's a good README on the Linkerd failover extension at GitHub.
Yeah, so it's on the extension page, but we don't know that we have it in the docs. Great question, Adonai. Let me get that pulled up. Actually, let's just get the Linkerd failover operator pulled up. Get y'all the link to that. So give me just a quick sec. So for folks in the chat, here is the link to the failover operator itself. And we'll double check on the docs thing to make sure that it is linked in the website. If not, obviously we'll get that in. Great question, Adonai. Thank you. All right, fantastic. Andrew, you want to give any parting words? I know I asked you that.
No. Thanks again. Thank you, Jason.
Yeah, no problem.
Hope to see you folks soon.
Yeah, and there's tons of courses for Linkerd noobs, including on YouTube. There is a free course from the CNCF that will actually walk you through a lot of it. There are videos. If you're not already tired of my voice, you can hear me talk about it an awful lot. And of course, if anyone's going to be at KubeCon, hit me up there. I'm happy to point you at materials there as well and help you find an opportunity to earn one of our super cool Linkerd hats. I'll try and post something, Omar, in the workshops channel before we go. And if you didn't get a chance to join, let me just one more time. I'll share the Slack link. It is slack.linkerd.io. Please join the Linkerd Slack for any more questions. And y'all have a great rest of your day, and thank you for taking the time to attend with us.
All right. Thank you. Bye-bye.
Yeah.